The graph algorithm and graph data structures in the computer science is a bunch of nodes tied in a bunch of edges. Basically, it's like city and roads. And once you have city and roads, what do? You drive from one city to another because there is nothing else to do with cities and roads other than driving or checking what's happening on the next city, if there is a good park to view, and stuff like this. So a graph is a bunch of edges and nodes, and what we do with edges and nodes, we traverse them. We have nothing else to do with graph, with the nodes and edges. So let's say I want to find all the cities whose distance is 5 miles from my city. What do? I first need to be in my city, because if it's you and you need to find this, then you first need to get to my city. Luckily, we can describe a graph as a data structure of a map from a node to a list of neighboring nodes. Okay, so in Java, this would be the map interface, the hash map implementation, and tree node, which you already have in Java, and the list of tree nodes. So you have a map from tree node to a list of tree nodes, all the neighbors. And then what we could do is simply visit. This is the terminology. What does it mean to visit a node? We don't really visit it. We get a node and check something. For example, in our case, we want to check if the distance of all the neighboring, find all the neighboring cities with the distance of 5 miles. We check if the distance of all the neighbors in the graph data structure is 5 miles. If it is, returns it as an answer. If not, then we need to visit the neighbors of the neighbors. There is a catch here, because if you visit neighbors of the neighbors, then also the source city or something that you already visited could be the neighbor of the neighbor. What do? You don't be shy and use additional memory and put all the nodes that you already visited inside this visited, or also called the scene set or hash set. And whenever you visit something, you put it in the set or hash set. And because we wanted like an onion layers, finding all the cities whose distance is 5 miles, then you want to start from the closest cities, then move on to the farthest cities, and then on and on, like this. This is the BFS, the breadth first search. In the BFS, what you do is that you get all the neighbors, check the condition, put them in the visited or seen list, and then you want to put all of them inside the queue or a list. And then you want to go over this list again. Why do we put inside the queue? You could basically put inside the stack. But as long as what you do is get all the neighboring, somehow the neighboring cities, remove them from the queue, each one, visit all of their neighbors, and then add the neighbors back to the queue. But you don't add any neighbor back to the queue, any new neighbor back to the queue, if it's already in the scene list. So the basic structure of BFS would be, first, I want a queue of all the neighbors. I want a set of all the visited or seen list. Then take the source node, put it in the queue. This would be the starting point. Then loop as long as the queue is not empty. Loop it, check if the end goal condition, visit it. Check if the end goal condition is met. If yes, return the result. If not, visit all the neighbors of the neighbors that you currently visit. How do you visit all the neighbors? You first make sure that the neighbor that you plan to visit is not already in queue, because not already in the visited or seen set, because if it's there, you don't visit it. You already visited it. And then, if you plan to visit it, you mark it in the queue, you add this item to the queue, and after you added all the neighbors to the queue, you start with them one by another. So this was a brief terminology into BFS and graphs, where we have the scene, the visited, the queue, the data structure from a map of nodes into all the neighbors, and then this was there was an example of how we can find all the cities with some distance to the queue. So thank you for listening. I hope this was very interesting, and I'll see you next time.